All right, guys, for permutations, all right, there is something I do want to tell you. If you turn your calculator sideways, there's an X with an exclamation point. That's the factorial button. It will make your life a lot simpler for this assignment. Use it. All right, sorry we're rushing through. Learn to find the number of possible permutations. Factorial. An arrangement of objects or events in which the order is important is called a permutation. Last time the combination, it wasn't important. This time a permutation, it is important. You can use a list to find the number of permutations of a group of objects. So we're building on what we did yesterday. In how many ways can you arrange the letters A, B, and T? Use a list to find the possible permutations. We write them all down. There are 6 of them. In how many ways can you arrange the colors red, orange, and blue? We list the possible ones. Red, orange, blue, blue, orange, red, and we're going to get 6 of them. All right? There are 6 ways to order the colors. The order is important, so we do not have to cross out duplicates in this day's lesson. With combinations, the order is unimportant, so you do have to cross out duplicates. With permutations, the order is important, so you do not have to worry about crossing out duplicates. You can use the fundamental counting principle to find the number of permutations. Here's what that means. Okay? Mary, Rob, Carla, and Eli are lining up for lunch. In how many different ways can they line up for lunch? Once you fill a position, you have one less choice for the next position. Oh, Mary's in first. Now we only have Rob, Carla, and Eli. Then Rob is. Now we only have Carla and Eli. Do you see what they're saying? Each time there's one less choice, because each event depends on the other one. There are 4 choices for the first position. Agreed? There are 3 for the second position. 2 for the third position. And the person that's left, that 1, is for the fourth position. Did you remember probability of events happening in order? We multiply the chances. So since there are 4 people in the order, we take 4 times 3 times 2 times 1. That is called a factorial. When you take that largest number, or the number of people possible, and you multiply that and each order or each number descending in order. We multiply and we get, there are 24 different possible ways they can stand in order. Okay? There were 4 people, so we took 4 factorial. 4 factorial is 4 times 3 times 2 times 1, and we get 24. The fundamental counting principle states that you can find the total number of outcomes by multiplying the number of outcomes for each separate experiment. Oh, we did that with independent and dependent. How many different ways can you rearrange the letters in the name Sam? All right? There are 3 letters. So we can take 3 factorial, which means 3 times 2 times 1. Because if I pick S, I only have a choice between A and M. There's 2. If I pick M, then I only have A left. So there are going to be 6 possible ways. I had 3 items to choose from, so 3 factorial, which means 3 times 2 times 1, and I'll get my number of possibilities. Okay, we multiply those out and we get 6. A factorial, which I've told you about the last 2 slides, here's the definition, of a whole number is the product of all the whole numbers except 0 that are less than or equal to that number. 3 factorial is 3 times 2 times 1. Those are all the whole numbers less than 3 multiplied times each other. not including 0. 6 factorial would be 6 times 5 times 4 times 3 times 2 times 1, and be 720. You can use factorials to find the number of permutations, or the number of ways things can be ordered. So, how many different orders are possible for Shelley to line up 8 books on a shelf? There are 8 different things to choose from, so we think 8 factorial, which means 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1, and we will get a big ol' honkin' answer. Okay? That's where if you turn your calculator sideways, if I would put in 8 and look for that button that has the X with the exclamation point behind it, that'll do the factorial for me. Okay? Okay, number of permutations, 8 factorial, which is 8 times 7 times 5 times 2, and I did that already. And we multiply that out, 40,320 different permutations. Okay? How many different orders are there possible for Sherman to line up 5 pictures on his desk? So we would think 5 factorial, which means 5 times 4 times 3 times 2 times 1, and 120 are there. You're ready to go. These are when the order is important. You use a factorial, makes your life much easier.